So this is where x and y intercepts becomes a little bit more functional for us and useful. We are able to use x and y intercepts to graph an equation. Up until now, you've been using tables of values and calculating 3, 4, 5 different points and plotting those points to graph an equation. Well, with x and y intercepts, you can do a similar thing, calculate a couple of coordinates and plot some points, and then get a graph for your equation. So here's our example. Sketch a graph of the linear function f of x is equal to 4x minus 3. Remembering that f of x, or function notation, is a fancy way to say y is equal to 4x minus 3. Since the function is linear, the graph is a straight line. Determine the y-intercept. Well, from what we talked about in the last video, what do we know about the y-intercept? What do we know about this point right here? Well, we know that that y-intercept has an x value of 0. Okay? So whenever we are trying to calculate the y-intercept, we say, okay, the y-intercept, well, that means x has to equal 0. So I use that part of the data and I substitute that into my equation. Now in this case, because we're using function notation, I should probably continue with function. Oh, come on, erase. Function notation. So I'm going to say, well, if x is 0, then f of 0 is what? But let me start with the equation, because I should always start with the equation. F of x is equal to 4x minus 3. But I want f of 0, which is going to be 4 times 0 minus 3, which is 0 minus 3, which is negative 3. So my coordinate point for my y-intercept, where it crosses the y-axis, is an x of 0 and a y of negative 3. So I could plot that point right now. 0, negative 3, right here. There is my y-intercept. Okay? And I do similar calculations, and because I can, I'll change colors here for the x-intercept. And again, think back to yesterday. What did we see in this, in the previous video, what did we see about the x-intercept? Where does this graph cross the x-axis, and what is special about the coordinates of that point? Well, x-axis intercept says that y is equal to 0. So I use that fact. I say, well, if we're looking for the x-intercept, I know that y, let's change, oh yeah, y is equal to 0. Okay, so that means that f of x, whatever x has to be, is 0. So I go to my equation, f of x is equal to 4x minus 3. But now my f of x is 0, so this is 0. 0 is equal to 4x minus 3. How do I solve for 0? Well, I'm going to add 3 to both sides. Oops. Gives me 3 is equal to 4x. And then I'm going to divide by 4. Divide by 4, I get 3 over 4 is equal to x. So my coordinate point for my x-axis is 3 over 4, comma, 0. And I plot that point. 3 over 4, make it nice and big so I can see it. 3 over 4, 0, 3 over 4, somewhere in here. 3 over 4, 0. I'll make that bigger to make it more representative like the other one. There. And those would be 2 points. Now, the problem with only trying to graph with 2 points is that it doesn't matter where you put 2 points, you'll always get a straight line. I could draw a line right there. Well, what if I got it wrong and calculated it over here? Well, now there I have my straight line. Well, what if I calculated the first one wrong and it was over here somewhere? Well, there's my straight line. So I really don't know if I'm right or wrong. Okay? So what I really need to do is make sure that I do at least one other point. Okay? One other point is going to allow me to see if I've got my graph in the right place. So question 3 here says determine the coordinates of a third point and draw the line. Well, I'm going to say, you know what, let's calculate the coordinates if x is equal to 1. I go to my f of x equation is equal to 4x plus 1. Sorry, not plus 1, minus 3. That's ugly 4 anyway. 4x minus 3. Substitute in 1. Gives me 4 minus 3. Where did that come from? And 4 minus 3 is 1. So now I have one other point. 1, 1. And I go to my graph. And I plot that point, 1, 1, right here. And now you can see, well, I'm probably pretty sure that I've gotten them right. All 3 of my points do sort of lie on some kind of straight line. Sorta-ish, I missed, but let's try again. There we go. There's your straight line. And there's your linear representation of f of x is equal to 4x minus 3 using x and y intercepts. Okay. Now you're going to have to eventually be able to do these calculations. With the y-intercept, you make x equal to 0 and calculate. With the x-intercept, you make y equal to 0 and you calculate. Then you choose another point. It doesn't matter where. Find some other point so you have a third point to make sure that you have everything correct. Okay. Over the page, example 1 here goes real quick. So it says this graph shows the total cost for a house call by an electrician for 6 hours of work. The electrician charges $190 to complete the jobs. How many hours did she work? Well, I look over to my graph. If it took $190, this is 60, 120, 180, 240, 190, somewhere in here. Carry that over to the graph. Carry that down to the graph. It's going to be just over 3 hours. Looks like about 3¼ hours. So about 3¼ hours. Okay. Pretty simple to tell. So you're just reading from the graph. You can get all kinds of information from this graph. Okay, so reading backwards and forwards. Some questions noted at the bottom of the page here. On page 319, 323, there's also going to be some chapter review assignment coming up, maybe worksheets. We shall see. But just remember, in order to be better or get better at this stuff, you just need to practice, practice, practice.